In the example problem that we're going to be working today, we're going to be tackling a problem that electricians have to tackle in real life. And that is one where they have to determine how large of a fuse or a circuit breaker to put into a circuit in a home so that the homeowner does not try to run too much current through that circuit and end up causing his house to burn down, which obviously would be a big problem. I know that in my kitchen, most of my electrical outlets in my kitchen are all wired to the same breaker, circuit breaker. And so I have to be careful how many household appliances I plug in at one time. I can generally run 2 household appliances, like a rice cooker and an electric skillet maybe, but I cannot put in 3 because every time I try to plug that third one in, I end up tripping the breaker. Or if you would have fuses, you would call it blowing a fuse. What that means is that when I try to plug in 3 household appliances, I am pulling too much current, and that's going to cause a problem. So what you have to decide then is when you have a specific circuit, how much current should be running through it, and then what size of circuit breaker or what size of fuse are you going to put in there to make sure that you don't have too much current running through there, which is going to be a fire hazard. So this is the current the circuit that they have drawn in example 15.4. You can see that the 3 resistances are wired in parallel to one another, and so the current obviously has a choice which one it's going to go through. The first thing that I'm going to need to do here is I'm going to have to calculate the effective resistance for the entire circuit. And since they are wired in parallel, I'm going to use the effective resistance with the reciprocals in it. So it's going to be 1 over the effective resistance equals 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3. Okay, so therefore 1 over the effective resistance is 1 over the first resistance, which is 9 ohms, plus 1 over the second resistance, which is 15 ohms, plus 1 over the third resistance, which is 8 ohms. Okay, then when you use that cute little trick that I taught you in the last video where you just plug in the 9, hit the reciprocal button, plus 15, hit the reciprocal button, plus 8, hit the reciprocal button, equals, hit the reciprocal button one more time, and you should end up with an effective resistance of 3.3 ohms. Okay, now, in order to figure out which fuse I'm going to put in here, I'm going to have to calculate what my current is that needs to run through here in order to make this circuit work. And so in order to do that, I need to use Ohm's law, which is V equals IR. I know that the voltage for this particular circuit is 12 volts. I don't know what the current is, that's what I'm trying to find, but the resistance is 3.3 ohms. And so then when I solve for I, that is going to give me 3.6 amps. Now the problem tells us that the electrician has 3 sizes of fuses. She has a 2 amp, a 4 amp, and a 6 amp. Well, obviously if she puts in a 2 amp, the circuit is never going to work because she has to be able to run 3.6 amps of current through there. So I don't want to use this one for sure. She wants to get as close as possible to this one, but she can't go under it. So the best choice for this particular circuit is to put a 4 amp fuse in there. Okay? The second part of the problem asked us to calculate how much power can go through this circuit, how much power the circuit will draw. And anytime they ask you for power, you can either use your P equals IV, or you can use P equals I squared R. You should get the same answer either way. It doesn't matter. And in this particular case, I calculated I know the resistance, and I also know the voltage. So I can use either one of these equations, and it doesn't make a bit of difference. And in fact, I did work the problem both ways, and you get the same answer both ways. So if I would use P equals IV, then my current was, I calculated that as 3.6 amps. And and then the voltage was 12 volts. And so that is going to give me a power of 43 watts. And like I said, I could use the other equation as well. I could use P equals I squared R, which would be, I was 3.6 amps, and I would square that. And my resistance was 3.3 ohms. So if I take 3.6 squared times 3.3, that is going to give me also 43 watts. Okay, now obviously you don't need to do it both ways, you only need to pick one, but I did want you to see that in this case, I could use either equation and I'm going to get the same answer either way. Okay, so you can get some practice there figuring out what size circuits you have so that you know what type of fuse, what type of circuit breaker you need to put in there, and then also calculating power for some of these circuits.